Well, welcome to this online revision session for AQA M2, in which we were looking at the June 2011 question 1 involving energies. As you can see in this question, we've been told that the diver of mass 58 kilograms dives from a fixed platform. So let's mark the platform in, there it is. And that's 10 metres above the surface of a pool, which is down here somewhere. And she leaves the platform at a speed of 2 metres per second. It's only the weight acting on her, so in other words its gravity is the only force we need to consider. And Kim is being modelled as a particle which is initially 1 metre above, so her centre of gravity is 1 metre above this point. So initially we've got to calculate Kim's kinetic energy, and we know that kinetic energy is given as a half mv squared, and we know her mass is 58, and we know her speed is 2, so it's 2 squared, and so if we work that out we just get 116 joules. Fairly straightforward. 2 marks, one for the method using the half mv squared and one for accuracy. Okay, then it says by using conservation of energy find Kim's speed when she is 6 metres below the board. So that means she gets to some point down here, so that's 6 metres below the board. So in total, she's fallen a distance of 7 metres. We know her initial kinetic energy, and we can work out how much gravitational potential energy is lost as she falls. So we can say that the loss in GPE will be equal to mgh, where m is 58, g we know is 9.8, and the height change is 7, and so if we work that out we're going to get 3,978.8, and that'll be joules. Now we know that that loss in gravitational potential energy must be converted to kinetic energy. So in other words, this must equal the gain in kinetic energy. So the kinetic energy at, well, let's call that point B on our diagram. We call that point A where they started. We can then say the kinetic energy at B must equal the kinetic energy at A plus the 3,978.8 joules. And we know the kinetic energy at A was 116, so we need to just add that 116 onto that figure, and that will give us 4,094.8 joules. So that's the kinetic energy at B. But we know that the kinetic energy at B is also equal to a half mv squared. So we can say that a half m, which is 58, times v squared must equal 4094.8 J. So V must be equal to, well, double both sides, so it's 2 times the 4094.8, and then you've got to divide it by 58, and then that answer has got to be square rooted, so that's to the power of a half. And if we work that out, we will get something similar to about 11.88, which, if we round it off to an appropriate level of accuracy, 3 figures, we would get 11.9 meters per second. Okay, 5 marks for that part of the question. Well, a method mark for working out the loss in GPE, with an accuracy mark for getting the correct value for that, and a method mark for calculating the kinetic energy at B, and then a method mark for coming up with an appropriate expression for V, with an accuracy mark for obtaining an appropriate answer. Well, hopefully you found that answer helpful. For further assistance with your maths revision, please go to the Further Maths Support Programme website.